Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be using graphic organizers to classify sets of rational numbers. Before we get into classifying, let's look at a couple definitions. Now, whole numbers are numbers that start at 0 and count up. The set of whole numbers does not include negative numbers, fractions, or decimals. So, in other words, a whole number is very specific. It starts at 0 and then counts by ones going up. 0, 1, 2, 3, continuing to infinity. Now, integers is made up the set of all the whole numbers. So 0, 1, 2, 3, and their opposites. So the opposite of 1 would be -1, the opposite of 2 would be -2, the opposite of 3 would be -3. So it's made up of all the whole numbers and their opposites. The set of integers does not include fractions or decimals. So it has to be either a whole number or the opposite of a whole number to be counted as an integer, all right? Now, rational numbers is our broadest category. It's the set of numbers that can be represented as the ratio of two integers, and those are known as rational numbers. The set of rational numbers includes all the whole numbers, integers, fractions, and decimals. So, for example, if I have 0.33 repeating, that can be written as 1/3. Therefore, it can be written as the ratio of two integers. That's why we can classify that decimal as a rational number. All right. Now, in example 1, we have simplify each number if possible, then circle the sets of numbers each number belongs to. So problem A, we have -7. So is -7 a whole number? Well, let's go back and look at whole numbers. Whole numbers starts at 0 and counts up. So it does not include the opposite of whole numbers. So it's not a whole number. Is it an integer? Well, yes, because it's the opposite of a whole number. So it is an integer, and every integer is also a rational number. All right. -5.75 cannot be a whole number or an integer because whole numbers start at 0 and count by ones, and the only thing -5.75 can be classified as is a rational number. All right, 1/3 cannot be a whole number or an integer. It only belongs to the set of rational numbers. Now, C was a fraction, and we classified as a rational number. So you may be tempted to think that problem D is also only a rational number. But 56 divided by 8 will simplify to 7, and 7 is a whole number. And every whole number is also an integer, and every whole number and integer is also a rational number. All right? E, -48 divided by 8. Well, we know 8 will go into 48 6 times. So this will simplify to -6. So it can't be a whole number, but it can be an integer, and every integer is also a rational number. All right, pause the video and try problem F on your own. All right, welcome back. Hopefully, the only set of numbers you picked that 1 1/4 belongs to is the set of rational numbers. All right, example 2. Use the hints and the numbers below to write the number each clue describes. So problem A, I am both an integer and a whole number. So our first number is -3/4. Is it an integer? No, so it can't be -3/4. All right. Our second number is 32. Is it an integer? Yes. Is it a whole number? Yes. So 32 meets this qualification. All right. B, I'm a rational number, but not an integer. So our first number is -3/4. And -3/4 is a rational number, and it's not an integer. So I'm going to put that there. C, I'm an integer, but not a whole number. Well, that would be -5, because -5 is the opposite of a whole number. In example 3, label the graphic organizer and use the organizer to classify the numbers below. So here in this graphic organizer, we have 3 ovals. Now, I always start with the smallest category first, which is whole numbers. Then I go to the next largest category, which is integers, which is all the whole numbers and their opposites. And then my largest category is always rational numbers, because every whole number and every integer is also a rational number. That's why it's embedded into the big oval. All right. Now, when you're classifying a set of numbers, what you want to do is always start with the smallest category and decide where it goes. So if I have the number 3/4 that I want to place in my graphic organizer, I ask myself, is 3/4 a whole number? No. Is it an integer? No. So it must go in the rational numbers category. All right, -10. Is -10 a whole number? No. To be a whole number, it has to be positive. So is it an integer? Yes, because it's the opposite of the whole number 10. So -10 would go in the integer category. Now, -10 is also a rational number, but we're putting it in its smallest category. All right. 23, is it a whole number? Yes. 0 is also a whole number. All right, 6 1/3, not a whole number, not an integer, so it must go in the rational number category. All right, 1.5, not a whole number, not an integer, so it must go in the rational number category. All right, example 4, label the graphic organizer and then use the organizer to classify the numbers below. Pause the video and try this problem on your own. All right, welcome back. Let's see how you did. All right, I always start with the smallest category, which is whole numbers. And then the next largest category, which is integers. And then the largest category, which is rational numbers. 15/3. Now 15/3 will simplify to 5. So I know that 5 is a whole number. So 15/3 would go in the whole number category. All right, -12 is not a whole number, but it is an integer. So hopefully you place -12 in the integer category. 1/8 was not a whole number, nor was it an integer. So hopefully you placed it in the rational number category. -36/4 will simplify to -9. So hopefully you placed that in the integer category. And then 3.2 was not a whole number, not an integer. So hopefully you placed it in the rational number category. Now, if you need to, pause the video to correct any of those that you might have gotten incorrect. All right, example 4. Which numbers below would not be located in the shaded region? So the shaded region in this problem is the integers. So they're asking which of these could not be located in the integers. Circle all that apply. Pause the video and try this problem on your own. All right, welcome back. Problem A, -8/2 simplified to -4. So that would go in the integer category. D, 2.0 is a whole number. So I put it in the whole number category. -33 goes in the integer category. 11/8 goes in the rational number category. -4 1/4 goes in the rational number category. And 1.25 goes in the rational number category. And they want us to circle everything that is not in the shaded region. So that was 2.0, -4 1/4, 11/8, and 1.25. If you need to, pause the video and correct anything that you got wrong. All right, example 6. Give an example for each of the following. Problem A, a number that is a fraction and a negative integer. Well, we have an example of this in example 5. Negative 8 over 2 is a negative number. A negative simplifies, it's a fraction, and it simplifies to a negative integer. All right. Problem B, a number that's a decimal and a whole number. Well, we also can find an example of this in example 5 also. 2.0 is an example of a number that's a decimal and a whole number, because 2.0 simplifies to the whole number 2. And that concludes today's lesson, classifying sets of rational numbers using graphic organizers.